Let's look at that place value a little more carefully. Here's our base 10. This would be the units column, or the ones column. This is the tens column. 10 times 10 is 100. 10 times 10 times 10 is 1,000. 10 to the fourth power is 10,000. See, we have 4 zeros on that. We have 4 as our exponent. And on this one, we've got 5 zeros on this one. So we have 100,000. There are no zeros on this one. We just have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 that could go into the ones column. And then as soon as we're talking about a number in this column, perhaps 12, we would have 1 10 and 2 ones. All right, that takes you back to like an early elementary on that one. But now this whole idea of place value, I want to put it forward to you when we start working with polynomials, that our x values or our y values, when they're squared and cubed, they fit in, those are labels that tell you what place value those are in. So here we would just have our plain number, because that would be the x to the 0 power. So that would be numerals like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. X to the first power is just a plain x. So it would be like if you had 2x. That would be an example of just a single letter in this column. This would be maybe like +3. And then when we get to this column, we've got an x squared. So let's put in there 7x squared. It's a column. And maybe we'll have a negative, that will make that negative, and this one we'll put in 63x cubed. Possibly in this column we could have a 70 x to the fourth power. And over here we'll have 3x to the fifth power. So the exponents on these different polynomials tell you the column that they belong in. So if we have something like this, 4x to the fifth minus 2x to the fourth plus 6x to the second plus 4x to the fifth belongs in this column. Our negative 2x to the fourth belongs here. Then we have no number in this column at all. So the x to the second has to be placed here. You would basically have +0 to the x cubed if you wanted to fill it in. And then +3 belongs here. So we don't have anything in this column either. So sometimes these columns are skipped altogether. And your equation or your polynomial just looks like this. But this is the actual place value, where every single column is accounted for. And if we've got a skip, that is sometimes just not shown. This tells us the degree of the polynomial. It's the highest exponent that you have. And when you put your polynomial, when you write your polynomial, it should be in descending order of the exponents. So this wouldn't be correct. It would be confusing, let's put it this way. If we said 6x squared minus 2x to the fourth plus 3 plus 4x to the fifth. It would almost be like you were reading the number, it would almost be like you would read the number 1,345 as putting the 3 here and the 1 there and the 5 here and the 4 over here. It changes the meaning of it. It's not quite as egregious as this example, but still this is hard to understand. This is much easier to understand if the elements of the polynomial are in descending order of the exponents, that one being to the 0 power.